Before going to the XtremIO demo, let me first cover how the lab is configured. One UCS chassis with two B200M3 blades, and each blade has a Windows Server 2008 VM on it. Each VM is configured with its unique full 1TB physical RDMs that are presented directly from the XtremIO box. The faxes on the back of the chassis are connected to 6120F fabric interconnects. And unfortunately, yesterday one of the blade on the second MDS switch died, so I had to connect the fabric interconnect B to the same 9222I switch as fabric interconnect A. Then we used some zoning to make this look like two fabrics. So one HBA from UCS blade 1 is zoned to the purple links, and the other HBA on the same UCS server is zoned to the green links as shown. We'll discuss how the ports are connected later on in the demo. So before we go into the demo, just reference documents, IDC, All Flash Array Performance Testing Framework, on why you should be testing an not just an XtremIO box, but all flash arrays. I highly recommend reviewing the user guide, the XtremIO user guide. It talks about certain settings that need to be set on individual hosts depending on what operating system you're running. And then there's this community URL here that will help you test an all flash array. It talks about there's OVFs available on this link that you can download to test the XtremIO box. Okay, so now let's go into more detail on how the vCenter is set up, because I'm running ESXi 5.5 on the two UCS blades. So I have my own cluster that I created for just XtremIO. There's these two blades that we already discussed, and these two VMs that we're going to be running the IO meter on to see what kind of numbers we get out of the XtremIO box. So let me do edit settings on this first VM. As you can see, it has 4 RDM devices presented to it. These are 4 1TB devices, and the same holds true for the other VM. Has its own RDM devices presented to it. One thing I forgot to mention is the lab configuration. Notice that these are single 4 gig links. So my bottleneck in this performance test are going to be these two connections, and I'll show that to you later in the demo, but just wanted to make sure that you're aware of that. I only have a single connection from each fabric interconnect running to the MDS 9222I switch. Okay, let's go back into Virtual Center. So we talked about the two VMs, how they configured physical RDMs, and then I also wanted to bring up these two documents that I discussed a few minutes ago. This is the IDC document. It talks about why you should perform testing on an all flash array, and this document is from the support.emc.com website. Once you open this document, go to the host configuration tab, and in my case I have VMware vSphere. It talks about certain settings that have to be set on the ESXi host to get the best possible performance out of the XtremIO box. So it talks about the this scheduling quantum setting to 64. It talks about max IO size 4096. It also has specific requirements to UCS blades as well. So if you scroll down, you'll see all the requirements that need to be set on ESXi 5 hosts as well as the UCS blade. So if I scroll down, I'm going to see something specific to the UCS, and the IO throttle count should be 1024. So just to show you in my lab how I have that configured is in the UCS manager. I created a FC adapter policy, and I set the IO throttle count to 1024, and then I set that on my service profiles as well. So these are my two ESXi hosts. This is the first HBA, and it uses the adapter policy of XtremIO. The same is true for the second HBA as well as the second service profile for the UCS blade. And just to show you some of the settings that had to be changed, advanced settings, disk. There's one of them. So just follow the document, the user guide from the EMC support website, and once you make all the changes, you should be good to go. Okay, now let's talk about the XtremIO interface. So when you log into the XtremIO box, you're going to see this interface. So I'm running IO meter on the two VMs already. We'll talk about that in a little bit. But the top left-hand corner, you have the overall efficiency, the dedupe, and provisioning. In this lab environment, I only have one data store with a handful of VMs. Everything else is physical RDMs, so I really don't have anything that can be deduped. Everything is thin provisioned automatically, so thin provisioning savings, volume capacity. So I have a 110 terabyte volume at 8 1 terabyte volumes presented. The 10 terabyte volume is used to hold a handful of VMs. In the bottom left hand screen, you'll see a nice picture of the XtremIO box. So if something does fail, it will alarm you right here on the screen. So let's take a look at click on this and let's take a look at this as well. So first you can show the front or show the back. So this is the front of the array with the two storage controllers with the 25 drives and the battery backup units. So let's take a look at the back. As this is similar to the PowerPoint that I presented a few minutes ago. So these are the ports that we connected. So if you hover over this, you're going to actually see the worldwide port names of those ports. So these two ports are zoned to one HBA and these two ports are zoned to the other HBA. These are red because we haven't connected those. Those are 10 gig iSCSI ports. Another nice thing about this is you can also show the cables as well. So you can see 8 gig fiber channel cables, iSCSI cables, management cables, and so on. Okay, so let's take a look at these two ports here. So this is ADC1 ending in ADC1 and 84D. So if I go to my switch, I run the show zone set active. So show zone set active. As you can see, there's single initiator multiple target zoning. ADC1 and AD4D is zoned to HBA0 on UCS ESX06, and HBA1 is zoned to the other two ports. And the same applies to the second ESXi server. So again, HBA0 zoned to AD4D, ADC1, and HBA1, AD4C, and ADC0. Again, this is just to make it look like two fabrics. So now that we've seen how the UCS hosts are zoned to the XtremIO box, let's go back to the XtremIO, go back to the dashboard. So we talked about the left-hand side. On the right-hand side, kind of see three tabs: bandwidth, IOPS, latency. See how much bandwidth I'm utilizing. I'm running IO meter on two VMs, so I'm really saturating those two for 4 gig links, and that's really my bottleneck in this environment. The writes are displayed in dark blue, and the reads are displayed in light blue. So I'm running IO meter with the 70% read, so that's why you're seeing about 70% is read and 30% is write. And down at the below, you'll see any alerts that are that we have on this particular array. So no alerts on this one. Let's go to the configuration tab. This is where you create LUNs and assign to different initiator groups. So I have one initiator group here with 6 ESXi servers. I'm only using 2 of those right now, but creating a volume is very simple. So you can just click on the add button, give it a name. So I can call this test, give it a size. We can say 1, or we can actually add multiples if we wanted to. So let's say we want to do 2 volumes, volume test. We'll start with index 1, and let's say these are 2 terabyte, and then click OK. Click next, click finish. So here's my 2 volumes. If I want to assign those 2 volumes to my production ESX cluster, all I have to do is click on this and then map all and then apply. So now I added 2 more 2 terabyte volumes to my ESX cluster. If I go to my virtual center, do a quick disk rescan. Disk scan completed. Let's take a look at the storage adapters. And if I scroll down, let me find my 2 terabyte volumes. Here's the first one. And here's the second one. Okay. So that's how easy it is to create volumes and assign them. We can also unmap them. So we unmap these 2 volumes from the ESX host. All the other ones are still mapped. So if we go to Virtual Center, do a disk rescan, we can get rid of those. It's very easy to create volumes, and again, everything is tin provisioned. Hardware, we already talked about that. Show the back, show the front, and whatnot. Alerts, any critical alerts on the array, you can see it here. You can monitor the array as well, so you can create tables, charts, and whatnot to look at the array performance. There's administration, SNMP, email configuration, additional users, and so on. So now let's go to the 2 VMs. I've been running this test for about maybe 10 minutes or so, IO meter test. So let's go to these 2 test VMs. So I have IO meter running. This is access specification is 4K, 100% random, 70% read, and I'm running it on all 4 volumes. So as you can see here, I'm doing on this particular VM almost 90,000 IOPS, and on the second VM, against same access specifications, I'm doing about 106,000 IOPS. So I can correlate these numbers to XtremIO. So if I go back to the XtremIO, my bandwidth is about 775 megabytes per second. If I go to the IOPS tab, I'm doing almost 200,000 IOs, and you can kind of see the histogram here, the history. These are the writes, these are the reads, and then the latency. So I'm doing all 4Ks, so the latency is less than 1 millisecond here. And again, I've been running this test for about 10 minutes now. One thing that I forgot to mention is the number of outstanding IOs and the IO pattern. So we're doing 32 outstanding IOs per each disk. So worker 1, the second disk, is doing 32 outstanding IOs fully random. Worker 2 is doing the third disk, fourth, and fifth. So everything is set at 32 outstanding IOs fully random, and the same applies on the second VM, 32 fully random. Go back to the first one, take a look at the results, and we're still doing 106,000 IOs, and on this one we're doing about 90,000 IOs. So again, the limiting factor in my lab configuration is the fact that I only have 2 1 gig links. So this concludes the XtremIO demo. If you're interested in running different IO patterns, maybe 8K, 100% read or 100% write or 50-50, feel free to reach out to us, and we'll be more than happy to run different tests on this lab environment. Thank you for your time.